Hi, I'm going to do another related rates problem. This one is from 2002, question number 5. Again, I'm going to keep stressing what I keep saying over and over and over again. Anytime you have any type of word problem, the first thing you do is read. The second thing you do is reread it. It may take another 30 seconds to reread the whole problem, but it'll allow you to read, visualize everything you need to visualize. No matter what the problem is. The third thing you're going to do is draw a diagram if you can. In this case, the diagram once again was given to you. The third thing you're going to do is label the diagram. And here's the key parts. We know this is 5. Why? Because they told you this is 10. They want you to figure out the volume when the height is 5. Well, let's look at the relationship. Height is 5, height is 10. Radius is 5. So what's the radius going to be in this case? Half of that, 5 over 2. Now let's work with the formula. Okay, volume equals 1/3 pi r squared h. The rest is easy. All I'm doing is substituting in what I know. Volume equals 1/3 pi r squared 25 over 4 times the height, which is 5. So 125 pi over 12 is your volume. Cubic centimeters. That's it. We're finished. That's part A. Now for part B. I want to find how fast, and let me read the question to you. If I'm telling you straight out, water in the container is evaporating, H is changing at a constant rate of -0.3 centimeters per hour. Let's look at what I'm doing. I'm labeling my diagram all over again. H is changing at -0.3. So dH dt is -0.3. Let's see what we know. V equals 1/3 pi r squared h. We know h is equal to 5. In this case, we know dH dt is equal to -3 over 10. But wait a second. I have a little bit of a dilemma here. I don't know anything about R, but I do. Let's look at what we have. We know of a relationship. We have R and we have H. Well, I can say the relationship of R to H is equal to, in this case, when H was 10, R is 5. So 5H equals 10R. And if that's the case, R is equal to H over 2. 1/3 pi r squared H. R is equal to H over 2. So what I can say now is V is equal to 1/3 pi H over 2 squared times H, which gives you 1/3 pi H cubed over 4H, H squared over 4H. I'm jumping ahead, I'm sorry. So volume is equal to 1/3 pi H cubed over 4, which is equal to pi H cubed over 12. Let's look at what they're asking now. Using this, can I see how fast the volume is changing? Sure I can. If I differentiate, dV dt is equal to 3 pi h squared over 12 dH dt, dV dt is equal to pi h squared over 4 dH dt. And the only thing I'm going to do right now is substitute. Well, we know h is 5, so you got 25 pi over 4. We know this is negative 3 over 10. And 5, 2, 5, 5. So you're left with negative 15 pi over 8. Let's look at what this means one more time. This means the volume is decreasing. Again, as I said, I tell my students straight out, write a sentence. I don't care how much you think it means, write a sentence in my class, and therefore it's making you understand what you're doing. Volume is decreasing at a rate of 15 pi over 8 centimeter cubed per minute, hour, whatever it is. In this case, per hour. And that's it. Now we're finished with that part. Let's look at what we have now. Pi r squared h. We know volume. Let's look at part C now. And if I look at it, it says, show the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area. Let's before I go through it, let's look at what it means. Well, when the height is here, we have a pretty small surface area, correct? When the height goes up to here, look at that surface area. Look at the area of that surface. When the height's up here, the surface area is bigger. When it's down here, the surface area will be smaller. And obviously, if fluid's coming out, we know for a fact surface area will decrease. Okay? We know dV dt is equal to pi h squared over 4 dH dt. And we know for a fact already from the given example that dH dt is negative 3 over 10. So dV dt is equal to pi h squared over 4 negative 3 over 10, which gives you pi h 3 negative 3 pi h squared over 40. But wait a second. Do you remember? Let's go through that relationship again. R over h is equal to 5 over 10. So 10R is equal to 5h. And if that's the case, h equals 2r. Because I need to know the surface area. And what do I need for surface area? R. So let's substitute, instead of h, let's put in 2r. So now I got negative 3 pi 2r squared over 40. And if that's the case, we're left with negative 3 pi 4r squared over 40. And of course, this and this gives you 10. So we're left with, ultimately in this case, negative 3 over 10 pi r squared. Wait a second. Area of a circle is pi r squared. Look at that, pi r squared. Pi r squared. So how is the surface area being changed? Well, proportion of surface area change is negative 3 over 10. There's your K. Thank you, and I hope I was able to help you understand a little better the idea of working with cones and volume and the related rate process.